Welcome to the Vibe Coding Blueprint, understanding the brain before you build. This is part one of a two-part series on vibe coding. But what exactly is vibe coding? Basically, it's just coding with AI in a way that actually works. This video covers the theory, how AI models actually work, what context windows mean, and the fundamentals of prompting, the stuff you need to know before you start building. The next video will be about practice, tools, and real examples. So let's get into it. You probably use ChatGPT. You type something, it responds, pretty straightforward. But the focus of this video isn't ChatGPT. It's what's actually happening underneath. That chat window is just one way to access the model. Behind every AI interface, ChatGPT, Claude, Gemini, there's an API, and that API connects to the actual model. The model doesn't care how you talk to it. Browser, terminal, Python script, it's all the same. Same model, different interfaces. Once you get this, you realize you're not just stuck with the browser. You can use the terminal with Claude code. You can write scripts that hit the API directly. That's where the real power. What actually happens when you hit send? Let's break it down. Your text gets packaged into a JSON request with your model name, your message, parameters, basically just structured data. That request goes to an API endpoint, basically a URL that the model listens to. It's how you talk to the model programmatically. The model processes it and sends back a response. Each time you click generate, that is what's happening. Request, process, respond, that's it. Once you understand this pattern, you can build your own tools, automate workflows, integrate AI into whatever you're building. The API is how you actually use this stuff. But how does AI actually know what to say? And this is where it gets interesting. It doesn't think like we do. It calculates. Every word gets converted into a vector, a point in a huge multi-dimensional space. The model learns relationships between these points. King and man have a specific relationship in this space that is represented geometrically. If you take the vector for king, subtract man, and add the vector woman, you can get queen. Not because AI memorized this, but because of how they're positioned mathematically in this space. When you prompt the model, it's finding the most likely next point in this space. It's navigating relationships, not recalling facts. That's why it can make connections that almost seem random, but will actually make sense. If we zoom out, you can see the full picture. Related words cluster together. Countries in one region, animals in another, emotions in another. The model organizes concepts by how close they are mathematically. When the model generates a response, it's moving through this space, jumping from one cluster to another, following the relationship that it has learned. This is why it can make analogies. It's seeing things that are visually close inside of this geometric space. The model doesn't understand things like we do, instead it navigates it like a map. But how can I vibe code with this? Well, let's look at this in practice. Not all models are the same. Let's zoom in on Claude's family. Haiku is fast and cheap, perfect for quick tasks, like file navigation or simple operations. Sonnet is like the middle ground. It's good for just everyday tasks. And Opus is the powerful reasoning model. That one's designed for complex coding and reasoning tasks, and it's the go-to for anything complex. These models don't come without a cost, though. Your prompt is broken up into tokens, each one about 4 characters long. For smaller models, like Haiku, this means that their costs can be really cheap. But for larger models like Opus, tokens can cost thousands of dollars if remained unchecked. This is why it's important to understand what model we are using, that way we don't use it too much of our plan. Every model has its own context window. This is its own short-term memory. Think of it like a bucket. 128,000 tokens sounds like a lot, but when you're using an entire codebase, document, and conversation history, it fills up extremely fast. And as this context grows, so does the computation cost. This is why we compact our history. When the model summarizes your history, you lose the nuance inside of it. The specific bug in your code? Gone. The exact file path? Now it's just general files. All of these important details get abstracted away in the sake of storage. This is why long sessions get weird. The AI seems to forget things that you tell it every time it compacts. It's not forgetting, it just doesn't have access to it anymore. But how can we get around this context overflow? By storing our own context within the file, we can choose what ideas are stored. This means, at the start of your project, if you can map out the entire structure from start to end, everything you want, and store it in a file, the AI will remember that consistently throughout the entire project. This will give it a baseline to go off of. We'll get into this more in the next video. Each AI has its own benchmarks. These benchmarks are commonly used to rank them. Here is one ranking I found online for January. Gemini 3 Pro has a very large context window. This is perfect for entire code bases or large documents. DeepSeek v3.2 has the cheapest cost. O3 has the quickest speed for generating. GPT 5.2 currently leads in intelligence. There is no single best model. What I'd recommend is to use different models and see what works best for you. Different models have different training data. So if one model is trained on data that's not relevant to your project, it might not be as effective as another model. Intelligence indices don't measure if it understands your project. It measures if it can understand projects generally. In the past few years, a few companies have highlighted themselves as leaders in the industry, namely ChatGPT, Anthropic, They all tend to release premier models at just about the same time, all with very similar metrics. They are competitors of one each other in each other's own AI environments and workflows to rope you into. All of this so far is just a theoretical view. In the next video, I'll go over a practical AI workflow that will allow you to make any piece of software that you want. This is my first time making a video in this style, so let me know if you liked it. And shout out to 3Blue1Brown for the video style and Vincent Rubinetti for the music.